But I'm here today to talk specifically about scrapers. And what I want to do, if you remember kind of the way I normally do demonstrations, there's always a lecture and then there's a laboratory. Okay, that's the way I do. And we'll spend a few minutes talking about kind of the theory behind scrapers. But I want to do a kind of a census first here. How many people in the audience have been turning for less than 2 years? Okay, so that's that's approximately 25%. So that's important. I want to make sure that as you're going through, you get the basics of that. How many people have been turning, say, 10 years or less? All right. How many people over 10 years? The old farts. Okay, good. Okay. So for those of you that just raised your hand, I want you to think about what I'm saying, how you use your scrapers, how you do it differently, and how you do it the same. So hopefully everybody can benefit from this presentation this afternoon. What I'm going to do first is go to the PowerPoint. We'll talk about the PowerPoint first. To do that, you don't have to see me, and I have to work on the computer screen with a little laser pointer to be able to point to different things. So I'm going to actually be sitting down here, but I'll be pointing, because there's two screens. I can't point on either screen. A laser pointer, my hand will not work. So we have a technologically built-in laser pointer in the PowerPoint that I will use. So when we get through that presentation, it will go over the theory behind scrapers. And I want to remind people that scrapers came long before gouges of any kind. Wood turning goes back to the Babylonians 5,500 years ago. And they would take spindles and they would have some apprentice, they would wrap a cord around a spindle and pull the spindle back and forth, and someone with a scraping tool would turn the piece to shape, but it was a vertical thing. And even the Vikings, again were people who advanced the turning community extensively, they did spindle turning horizontally. They used a spring pole type thing. But all of their tools pretty much were either scrapers to start with, or they developed this other tool that's called a hook tool, which is the first step in getting to what we know today as our modern gouges. So all of you guys who are using the spindle roughing gouge, who are using bowl gouges, spindle gouges, they are the newcomers to the turning world. Scrapers go back well over 2,000 years before we were using gouges of any kind. So what I want to do with you today is talk about scrapers. What are scrapers, different versions of scrapers, how they work, and talk about tools that you may not even think of as scrapers. We have a couple of tools that people use incorrectly as scrapers. So I want to correct that if people are doing it incorrectly that way. And then what we're going to do is we will finish the PowerPoint talk. We will then come to the lathe, and I'll demonstrate the use of some scrapers in terms of tool presentation and position. Also, during the PowerPoint talk, I will mention a few things about sharpening scrapers. They are among the most simple of wood turning tools to sharpen. If you have a platform and a stable grinder, the likelihood is you can easily raise a burr and sharpen a scraper. But remember that sharpening of the scraper fundamentally lasts only a few seconds. That burr is there for a relatively short amount of time. The harder the wood, the shorter the time that burr is there. So that means that you have to go back and continuously refresh that burr, because that's the thing that actually does the cutting. Okay, so I'll mention a few of those things along the way. Are there any questions or any specific questions that you want me to address today in terms of your questions about scrapers before I get started? Okay, well, let's see how that goes. Hopefully by the end you may have a few questions. All right, so now Tom, are we back on? There we are. Okay, so let me get to my little pointer here. And if I can do this and this. Can you see the bouncing ball? right here. Okay, so you can hear me. I don't need to face you because I'm going to be watching this screen and going through this talk. So what we're going to talk about here, as I just mentioned, we're going to talk about the utility of scrapers as a wood turning tool, and I want you to make sure that you understand the difference between shearing cuts and scraping cuts, bevel registered cuts and edge only cuts. This is basically what we're talking about, and I'll show you those differences. So you will see also the difference between using a traditional scraper, which is presented at a negative angle. I'll also talk about the big thing that everybody hears about, this negative rake scraper that's very popular now. I'll explain the differences, why the negative rake scraper actually works in a much easier way than a traditional scraper, although both tools are almost equally as effective if you use the right technique. Okay, and then we will talk about shear scraping, and we'll talk about the difference between flat or horizontal cuts that are true scraping cuts. We will talk about a range of different shearing cuts, and then a slicing cut, which is basically at 90 degrees to the rotational axis of the lathe. And then there's a few other tools like hollowing tools and the carbide insert tools that are used in a scraping mode. Many of you may be using those already. Okay, so when we look at this, I want to set the stage initially by talking about the tool rest. Well, why would I want to talk about the tool rest? We're supposed to be talking about turning tools here, right? Why do we need a tool rest? Who wants to answer that? Why do we need a tool rest? Stability. So what does that mean? Let's pick apart that word, stability. What? Be able to hold it steady. If I came up to the lathe and hold it, I pick up a gouge, and even some of you big burly boys out there with the big massive biceps, if I lay this spinning and I put that tool in there, what's going to happen? Something is mechanically going to change here, and I will crap my shorts. What's the point of the tool rest? I'll keep me from crapping, but we have kaopectate for that. What? You're going to hold the tool. This is energy, ladies and gentlemen. This is rotational force. If I transfer that force into that tool to try to make a cut, there has to be an equal opposite force against that tool to make the cut. What the tool rest does is it allows for the transfer of energy from that rotational force through the tool down into the tool rest, into the banjo, and dissipates that energy through the lathe. Whatever's left over from that whole energy conversion is used to, we'll call it in physics, deform the material on which we are working. So your cuts, your shearing cuts, your scraping, all of that is wood deformation that you're doing with that sharp edge of the gouge. The purpose of the tool rest is to help with that transfer energy, because without it, you are unable to turn. It's one of the most critical parts of the lathe, and it's the position where that force is coming around, as we'll see in a minute. As that force is coming around, one of the reasons why the contact point should be near the center line, and everyone's taught that, right? Make sure that you're cutting at center line. The reason for that is because all the energy that is being forced down comes off at 90 degrees to the axis of the radius of rotation. So if you have your tool, if you have the tool way up on top, you will have the energy coming straight into your tool, and you'll be having to push back into that tool just to maintain position. But the minute you put it down at center line, all of the rotation force goes down into the top of that tool and is dissipated through the tool rest. That's why we need a tool rest. And not only do we need one, it has to be in the right position. When we talk about scrapers, this is critical, because those of you who have never used a negative rake scraper will always have to have that tool rest slightly higher and a position presenting that scraper at a negative angle. So let's continue with the concept behind this. Why do we need to set that tool rest at that particular angle. So obviously the principle is that you want to have it at or close to center line, and as you can see here, if you have a tool rest that you can bring inside, that helps with the control of the forces in terms of the lever action that you have on your turning tool. And we can talk about that later if you like. But the purpose of that tool rest is to transfer energy from that rotational force down into the lathe bed, support the tool that you cannot do with your body, and allow for the controlled deformation of that wood in the shape that you want. That's the point of this. So to do that, the position of the tool rest must be in line with the forces generated. So you can't really try, it's better to have the force in one constant line because it makes it much more controllable. So the tool cutting edge, as I mentioned, should be either at or slightly above center line to ensure that most of the energy of that rotation is transferred through the tool down into the tool rest. If you set the tool rest too high, it requires additional horizontal force from the user, from the operator, to oppose that rotational force. I'll show you a diagram in a minute. Even slight changes in the tool rest position can have massively improved effects depending upon where you put that height relative to the spinning axis of the object. So here's a diagram that I want you to think about. This is looking at, say, the end of the lathe. So you're at the tailstock end of the lathe looking at a rotating piece of wood, this green thing right here. And what this diagram shows is several radii coming from the center point here, a radius that comes out to the edge. And basic physics tells us that if you touch the point here, say on top of the lathe, the force is going to come, the rotational force is going to come off of that point 90 degrees to that radius. And you can move that radius all throughout the 360 degree rotation of that. So these lines, these yellow lines here, are force lines that are coming off. So if you have your tool rest, which is what this red dot here, if that's the height of the tool rest, and if you set that tool rest right at the top of the piece, you will have to have as much opposing force holding the tool in position as there is force coming off of that piece. So if you set the tool rest too high, you have to have much, much more horizontal force to try to even control that tool. The reason why we have, and we recommend for people to put the contact point at the axis right here, at the center line axis, is because all of the force at that point is coming off straight down and be able to transfer that force down into the tool rest and dissipate it through the lathe. So the higher you put the tool rest, the more opposing force you need. This is a big deal with scrapers. This is one of the reasons why the popularity of the negative rake scraper is such, because virtually all of the force in the negative rake scraper is being pushed straight down because it's held horizontal at center line. Okay, so these things over here are there for the engineers and the science nerds. If you're an engineer, you remember basic vectors. How many people does that fit? 2, maybe 3? So you remember basic vectors, right? You have a certain horizontal and vertical component, and the vector quantity of those things is how much opposing force. So that's what we're talking about. All that does is explain the difference in if a high tool rest coming off here means that you need more force to oppose. The closer you get to being at center line, the amount of horizontal force is almost zero, and all of the force is directed straight down into the tool. So this is why tool rest is a big deal. Tool rest position is a big deal. The other thing I want to talk about before we actually start scraping things is talking about shearing or cutting versus scraping. This is a fundamental difference, a fundamental principle for beginners through experts. You've got to know this difference. What is the difference between shearing versus scraping? So, if we go to, here's an object being cut. Now this will just say we're looking now from the headstock side because it was the easier way to draw this. In a shearing cut, using, say, a gouge, a Badan tool, on a spindle you could use a skew, okay? The point of a shearing cut is that it is a bevel referenced cut. There is no space between the bevel of the tool and the surface of the wood being cut. So you are, what do they tell you? Ride the bevel, float the bevel, whatever it is, but the bevel has got to be in contact with the wood as a registration surface to peel off a nice shaving. If you pull away, if you're using, say, a gouge and you lose bevel contact, what happens? You get a dig in, you get a catch, you no longer have a bevel reference surface, and if that does it in a violent fashion, that, let's just say, is most unpleasant. Okay, that's not one of the fun things about wood turning. So riding that bevel in a shearing cut is absolutely essential. The difference in scraping now, if we go down here, scraping has a clearance angle down below here. There's no bevel contact when we're looking at a scraper. The scraping edge, the burr raised from the sharpening process, is really the only thing that contacts the wood. So the minute you start trying to do a bevel rubbing cut with a scraper, you can get into some problems. If you lose control of at least two of the rotational axes of the tool, you can get into a very, very bad dig. So presentation of the scraper in terms of height and in how much of the edge is contacted with the wood surface, both of those things have got to be very carefully controlled, or you lose control of the scraper, or the scraper acts in a self-feeding fashion, and in many cases can significantly tear out wood fibers and not scrape them off, and therefore you have a problem with not cleaning up the surface of the wood with the scraper, but creating even a worse surface with the scraper. So presentation of the scraper in terms of its angle and its pressure, its attitude, whether it's horizontal or at some angle, all of those variables can improve or wreck the surface of the wood that you're trying to improve upon. All right, so recently, at least we've been told, not necessarily this week, but recently we have actually had snow at some point. We're enjoying a relatively mild February so far. But in this case, if you were to use your snow shovel to clear snow like this and basically just have the edge contacting here and pull in that direction, how efficient would that snow removal be? Not particularly efficient. But if you come over here and you haven't sliced the snow off, you get not only a much cleaner surface down here, if you want to think of it that way, but also the efficiency of the removal of the material is significantly improved. This is the difference between scraping and shearing in terms of a practical example that you could try at home next time it snows. Now, hopefully it's not going to snow a lot between now and spring, but it's Iowa, it's going to happen. You know this. So try this. The other thing that you also remember is I don't know if this is pretty small, but these are trucks with plows that held at angles. You know, a shearing cut is, a scraping cut is often done square on, but a shearing cut is often done at some angle, which creates a difference in the forces involved with the removal of the material, and the shearing cut is far more efficient than a flat scraping cut, just simply because of the physics of the removal of the wood. That's the way it works. All right. So the short answer between scraping and shearing is that shearing is by far more efficient than scraping and leaves a better quality surface with less damage, less potential tear out, right? So when we look at this, these are kind of fine lines here, but with that no clearance angle in here, the bevel rides or the bevel rubs of that cutting or shearing tool, and it will peel off, particularly if you use some other sort of a more acute shearing angle, which I'll talk about in a second. That's a very efficient cut as opposed to a scraping cut. So if everything is great with shearing, why do we even need scrapers? Well, in the geometry of the kind of things we turn, sometimes we can't have a gouge fit every position and there will be lines left, there will be gouge lines left, or little ridges or something. And the purpose of scrapers is to try to remove those, unify or blend the entire surface, and leave a better quality surface than you could get off a gouge, so that it will reduce the effort that you have to do for sanding. That's the fundamental reason why we would want to use scrapers. Okay, so shearing versus scraping. Another thing about one of the concepts I want people to think about is this concept of shear angle. Okay, so everybody now just jump back to the second year of high school, and you're all looking at that stupid thing, remembering what the protractor was, right? To measure angles, to draw angles, and so on. And what I want to do is take that simple experience that you had long ago, and some of you may be more sooner than others, but you remember that a right angle is at 90 degrees, you have 0 degrees, 180 degrees, and the half circle, all of that basic geometry, right? Anytime you can take and understand what's going on with the tool, on why it works, not just how it works. You were shown how it works, but I would like you to understand why the tool works the way it does. That with the angle at which you present the tool to the wood can vary from being completely flat, having a 0 shearing angle, okay, so that you have it's laying dead flat, horizontal to the ground, parallel to the axis of rotation of the lathe, parallel to the lathe bed or ways, right? So that's at 0 degrees. If you stood the tool straight up, like you would do, say, in an end slicing cut that you would use on a spindle with a skew, maybe to square off the end at a tenon or something like that, that would be considered a slicing cut held at 90 degrees. So you'd go from one extreme of being completely flat, scraping, versus slicing. Those are the extremes. And any angle in between scraping and slicing can be considered a shearing angle. Okay, everybody seems to be with me. I have very few sleepers. There's a couple at the back there, but I want you to, and I'll show you this again, practically speaking, when we're at the lathe. But I want people to remember that you have the ability as a turner to determine what angle you present that tool. That if you can get good at holding the tool in the right position, even a flat scraper can be tilted up and position itself and be presented at some shearing angle that you will have to find empirically in actual use to find out what angle is best for the wood that you're using, for the shape that you're trying to cut, and ultimately then the rotational speed. There's a lot of variables that go into that, but you will find that you can still use a scraper but use it as a shearing cut. Some people call that shear scraping, right? So we will talk about that as well, and I'll show you that at the lathe. Now, about the tools themselves, let's talk a little bit about scrapers. There's a whole variety of different kinds of scrapers that are out there with respect to the shape. By and large, they are just bar stock of high-speed steel. And there's high-carbon steel out there, the older tools, the ones that if you grind them, it looks like sparklers, those kinds of things. Easily damaged by overheating during sharpening. But most of the modern tools that we have are some form of high-speed steel, M2 type high-speed steel or higher quality. And really, the only difference is how people grind the shape here. When you're talking about traditional scrapers, you can form any type of shape that you need and form a scraper out of it. So you can tailor the scraper to the job at hand. And I'll show you some physical scrapers at the front of the room here. I also invite you to come up after and have a look at them. But you can modify the actual shape of scrapers in pretty much any way you want. So the unifying theme behind all these traditional scrapers is that they are used flat, parallel on the tool rest like this, unless you are deliberately trying to induce a shearing angle. All right, so the traditional way, the way that you've been taught is to have your piece on the lathe, you have your tool rest set at a relatively short distance, because the shorter the distance, the less potential for vibration to be set up in the tool. Also provides a little bit more control. And remember, we're controlling forces here. The shorter the distance between the the force that comes in and where that force leaves, that shorter that distance, reduces the amount of effort that you have to have as a wood turner, and it also improves the efficiency of that energy conversion, right? So when you're doing traditional scraping, the handle of the tool is generally held up so that the actual presentation of the edge of that scraper is at a negative angle. All right, so most of you have been taught how to use a scraper. So to reinforce that, this is what we're talking about, the so-called pitch of this scraper being presented here, a traditional scraper now, at a negative angle, so that the only point of contact is at that very edge, that bird edge that you have after sharpening that scraper, right? So it's a handle up, tool rest close, presentation negative angle down. So it's at a negative angle relative to the center line axis, right? If you did a scraper in a positive angle, you will, I guarantee you will have problems. It will catch, it will push back on you, it will gouge the wood out. And this is where people start having problems with using traditional scrapers, because it is a finesse tool. It has to be applied to the wood with care, and it has to be applied at the right angle, or there will, I guarantee you, be problems. And this is where experience comes in. I mean, 30 years ago, I was learning how to do this, and I had all those problems a long time ago. I still use traditional scrapers, almost every project, but I also use negative rake scrapers. It depends on the project and the tool that I have ready at the time. So again, if you're using a typical scraper, you have to remember to always have that tool presented at that slight negative angle. Just 10 to 15 degrees is fine, but it has to be at, or in fact slightly below, that center line axis of the lathe. You can theoretically scrape down here, but you're going to run out of geometry. It's going to become a problem if you're too low. If you're too high, forget it. You're making serious mistakes. You're going to be having catches, digs in, and extracting surface material, catches, and generating tear out in a huge way if you present that scraper too high, above center line. So the bottom line, literally the bottom line here, is to make sure that that burr, which is out at the end here, engages at approximately center line. But you'll notice that there's a relief angle here. There's air, there's space between that edge and the surface of the wood that's being cut. Okay, and we'll talk now about the difference in each of these types, whether it's a traditional scraper or what we'll talk about now is this negative rake scraper, and why negative rake scrapers work the way they do. A negative rake scraper, here's a traditional scraper, so you have a relief angle, and when I sharpen mine, my relief angles are almost about 20 degrees, 20 to 25 degrees in that range. So the included angle here, if this is a 20-degree relief angle, that included angle at the tip of the tool is about what, 70 degrees. 90 minus 20 is 70, right? So this is how I sharpen all of my traditional scrapers. Usually it is presented to the piece at a negative 5 to 15 degree angle, again raising that handle. In contrast, what the negative rake scraper has is not just the relief angle beveled, and it can be exactly the same as the traditional one. I sharpen all of mine at 20 degrees, this lower angle down here. But what the negative rake scraper has is on its upper surface, it has an angle off this surface line right here, 10 degrees negative. That is what is called the negative rake, minus 10 to 15 degrees off the surface. It can be more than that, but that's all you need, 10 to 15 degrees. You don't have to grind away a huge amount of metal. And in fact, some people I know, friends of mine, even good friends of mine, have taken skews and converted all their skews into negative rake scrapers. Excuse me for mentioning that, Roger. Okay, but you know who you are. You can have 35-degree angles on each side and still be completely considered a negative rake scraper, as long as you have raised a burr on the surface that is going to be used on the upper side. You have to have a burr in place. So as Roger says, a sharp skew is a dull negative rake scraper. Does that make sense to everybody? There's got to be a burr on there. Okay? So in this case, you still, you don't have to do it every time, but you make your negative rake, you grind that negative rake angle in there. You can grind, and the last thing you have to grind is this relief angle surface down here, such that a burr is raised on that upper surface. That's the big deal. So that's how you make a negative rake scraper, right? Once you have that, there's your negative rake right there. There's your bevel angle, or the so-called relief angle. But the big deal that I know people have tried this, they've tried to convert a regular traditional scraper into a negative rake. If you have the wrong combination of this relief angle and the upper angle, if that angle is 90 degrees or more, you will not raise a burr and it will not work as a negative rake scraper. This included angle right here, and you can measure it with a protractor, that has to be less than 90 degrees. If it's less than 90 degrees, you will get a burr. It will work as a negative rake scraper. Okay? So remember, when you're grinding this, the angles matter. This is a traditional or ordinary scraper. In this case, just a 14-degree relief angle, but the included angle here is 76 degrees. I would need to cut this at an even shallower angle so that this angle up here is less than 90 degrees. This negative rake scraper will not work. I would have to increase, or actually technically slightly decrease that to make this angle right here more acute, less than 90 degrees. That's the edge where the burr is going to be formed up on this surface, because this is the last surface that you'll be sharpening. Okay, so that's how you make a negative rake scraper, but be sure that included angle is 90 degrees, actually 89 degrees or less technically. 90 will not work. Okay, so here you have some examples. Here's a traditional scraper sharpened to 77 degrees, 13 degrees. Relief angle here, and the burr is on the upper surface. On this gouge over here, it can be a very, very acute angle as long as this is the bevel that you sharpened last to raise a burr on that side. Does everybody understand that difference? Okay, you have two angles here, not just one. All right, so negative rake scrapers, they go through, they both engage a burr. Traditional scrapers is always presented at a negative angle. Negative rake scrapers are presented at a horizontal angle. So let's go back and understand why that is. Here's our diagram that you saw again, right? This is just remembering now. Recall that by having the force and the contact point, at that point you're going to be moving the force down directly into the tool rest. So if you put your scraper right here, the force will push that scraper into the tool rest, and you have very little force that you have to apply to resist any, provide any opposing force. Now, if we go to a traditional scraper like this, normally that scraper is presented at a downward angle. And what happens is that because of that negative presentation, traditional scrapers tend to be self-feeding. The burr will grab and it will want to push or pull the scraper down parallel with the forces as it rotates down through the axis down here, and all of a sudden you're getting too much feed because it's feeding itself. If you are not ready to oppose that force as you touch the wood, that scraper is going to get pushed into the cut. Okay? So this is the reason why many people have problems using traditional scrapers, simply because of that negative presentation angle, and they're not ready for the engagement of that burr and pulling of the tool into the wood. That's the problem. How many people have had that problem? You have significant tear out that you can generate using a tool that is supposed to be cleaning up the surface. But if you use it the wrong way, if you present it too high, or you're not ready, or you're presenting it with too much force, you will wind up with more tear out and a worse surface than you got off your gouge. So you've got to be careful and gentle and apply this in a traditional scraper in a very, very patterned, structured, and finesse way to make sure that that tool functions properly. I'll show you how that works. The reason why people have gravitated to negative rake scrapers is this. This is why negative rake scrapers work. In that same rotational axis, with a negative rake scraper, because of that top bevel, you present the tool horizontally to the wood and engage the cutting or the actual surface, despite the fact that you still have a negative clearance under here, a clearance angle below where the burr is. Because of that negative presentation, you are holding the tool at horizontal, and that means all of the force that is encountered by that tool is pushed directly into the tool rest, giving you an incredible amount of control without the risk of the tool self-feeding. They don't self-feed because you're only presenting the tool right at that center line. So all of the force is just being pushed down into that tool. And that's why they're so forgiving. That's why they're so easy to use. Particularly if you're looking, say, on the inside of a bowl, where you can easily, because of the curves inside, you can easily get catches, and you can get a traditional a traditional scraper to feed into that. Negative rake scrapers won't do that. And you can, with those kind of things, you can actually, most scrapers, you can use in both directions. You can use a push-pull cut. So in the theory behind this is that from your ordinary scraper, the traditional scraper presented at a negative angle, if you just simply change the presentation of this, the theory is that the wood, which encounters that burr, sees exactly the same thing, whether it's a traditional or a negative rake scraper, but the attitude of where the tool is being held is completely different. One's at a negative position, one's at horizontal position. This self-feeds, and this pushes all the energy down into the tool rest. That's why negative rake scrapers, for many people, are much easier to use. So I do recommend that you, at least if you haven't already, try grinding at least one of your scrapers into the negative rake configuration and think about this. Some people say, well, why don't you just hold the negative rake scraper at that negative angle and just tip it back? Well, guess what? As soon as you start tipping that traditional scraper back, you're now going to a positive rake, and now you're asking for the catch. You're asking for the gouge, the dig in. And that's not what the purpose of these scrapers are. All right? Question? Won't matter. They should be the same. There's no physical reason why one should be any more lasting than the other. It all comes down to how hard the wood is, how abrasive the wood is. You can do it on pine, and it will last you 10 minutes. You can do it on white oak, and it will be 45 seconds. Mm-hmm. You're only sharpening the bottom angle until it works back to the point where you have to put a new bevel on top. No, that's absolutely correct. Back there. I use 80. There's no reason to go finer. The burr lasts for such a short amount of time. You're going to be refreshing it very frequently. And remember, you got to think of your tools as consumables. You buy one scraper, it's not going to last you, or one gouge, it's not going to last you for the rest of your life unless you don't turn very much or don't do a whole lot of sharpening. So don't be afraid to touch things up. Scrapers do not last a long time. Some people say the life of a burr on a scraper is measured in seconds after it contacts the wood. So have your grinder close by. And just one quick touch, a 10-second or less sweep on that gouge just to raise another burr, sets you up with a brand new edge, and you go back right at it. There's a question over there. A burnisher. Yep. Mm-hmm. I did not bring mine because mine has been bolted to the top of one of my benches for about 30 years. What he's talking about is you raise the burr, and it is basically a piece of hardened steel that has a slight angle in it. You put the scraper on there, and you rub the edge, and that rolls up a more uniform burr, at least they say. I use them once in a while, but I find on my 80 grit CBN wheel, one swipe on the platform can raise another burr, and I'm right back at it. So as long as we're talking about burrs here, how many people have ever felt a burr on a scraper? How many people you have no idea what the hell a burr is? Okay, and no, there's nothing wrong with that. I'm going to burrow this tool right here, and I'm going to pass this around, and this has a burr on it. And all you need to do, don't run your hand parallel, okay? Because I have sycamore. I don't have bloodwood today, and we don't want bloodwood in the audience, okay? But I'm going to pass this tool around, and I want you just to, with one finger or thumb or something like that, you're going to come across like this, and I want you to feel what a burr is like if you've not felt one. Now, all of you guys that work in the ditches and have hardened skin and calluses, please leave a burr on this tool for the next person. Okay, don't scrape that off, because I know you could do. I'm a manly guy. I'm going to scrape that burr off, right? So don't do that. This is supposed to be so people can actually feel a burr. Okay, if you've never felt a burr, this is your time to get intimate with the burr. Okay, so feel that as it goes around. That's what you're shooting for. Now that gouge is a thick, what I call a long, strong scraper. And it's fairly thick. You'll have scrapers that are completely effective, but they're only 1/4 inch, like the Sorbies, right? They're only a 1/4 inch thick. That limits how far over the rest you can go without start getting chatter. But these, if you finesse these tools, are for smaller turnings. These are just as effective as that, and they still have a burr that feels almost identical. Okay, but that will give you an idea what the actual burr is like. Just a few more minutes here, and then we're going to start making some mess on the floor. Okay, so the last thing I'll talk about is changing the angle. Remember, both the negative rake and the traditional scraper are presented horizontal, parallel to the floor, parallel to the axis of turning or the bedways, right? What I want to talk about is changing that. You still using a scraper, so that means you have a single contact edge, not bevel rubbing. But that edge, that edge presentation, instead of being horizontal, we can pick it up at some angle and do what we call shear scraping or shear cutting. Now, what would be intuitively, what's the difference between shear scraping and shear cutting? The presentation, let's expand what that means. What's touching? Just the burr raised edge would be scraping. Shear cutting would be using a bevel. Most of you who use gouges do shear cutting all the time. And we can take a gouge, and I'll show you this up here. We can take a gouge, and if the grind on your gouge has swept back wings, which I use a lot, I use an Ellsworth type grind with swept back wings, and I can then magically convert the edge of that gouge into a very effective negative rake scraper by presenting just the edge and doing a nice shear cut at a steep shear angle, which leaves a surface that I could start with 150 or 180 grit sandpaper. And that's a scraping cut, but it's presenting the tool for use in a shear scraping mode. And I'll show you that difference. Okay, so when we do that, here's Tommy Silva. How many of you know that Tommy Silva is now a wood turner from Massachusetts up there? What kind of lathe he got? He's got a top of the line, robust lathe. And we met him at, where was it? It was at Louisville? At St. Paul. So we actually met Tommy Silva up there. Shook his hand for the first time after 30 years watching this old house and him making a fool of himself on the lathe up there. Anyway, Tommy is using a hand plane. Many of you have used a hand plane. Do you ever use a hand plane at 90 degrees? It works better not, the comment from the front of the room, right? So shearing cuts are more efficient than 90-degree square-on cuts because of the changes in the forces as the blade moves through the wood. It's another, for those of you engineers out there, it's another one of these vector things. You're transferring some of the force laterally instead of in line with the cut. So let's think about what that's going on here. You remember this, right? Scraping down here, 0 degrees presentation angle, 90 degrees slicing. Anything in between is a shearing cut. Is that? I don't think that's me, is it? That guy. Okay. I thought I turned him off, but in any case, my phone. If you look at the use of a traditional scraper, right? I want you to see that this is horizontal. A shear scraper is held at some shear angle. That shear angle is determined based upon the reaction of the shavings that come off during that cut. So I'll get it. The importance here is read your shavings. Don't just hold it there and expect it to be perfect. Read your shavings. The minute you start seeing this happening, where if the wood is coming over the top like this, a traditional scraper held horizontal, the shavings are going to come right off directly back, right over the tool, in line with the tool. Traditional scraper. If you look at a shear scraper, the wood's coming across, it's encountering it at some angle that's not 90 and not 0. The shavings will be directed off at some angle, depending upon the angle that you set off of 0 with the presentation of that tool. Same thing here. John Jordan makes a kind of a thin shear scraping tool like this, and the wood's going to come over, it's going to encounter the edge, and it's going to shoot these little fine, thin angel hair shavings coming off at some angle. So as you present the tool, keep an eye on where the shavings are going. Keep an eye on the quality of the shavings, whether they're thin, wispy little things. If they're coming off as chunks, something's wrong. You're having divots taken out. And the divots that you take out of the wood are nothing like the divots on the golf course that you could just put back. You're not putting divots out of your wood back on the piece you're turning. Okay, so you duffers out there, be sure that the divots that you're creating are only those on the links. Okay, so read the direction of where your shavings go. Traditional scraping will be right back. A moderate shear angle will have them deflecting at some angle like this, and then a steep shear angle will have them coming off. In some cases, they can come off almost parallel with the axis of turning of the lathe. So read your shavings. Now, when we talk about scraping tools, there's a few leftovers. We're not talking about negative rake or traditionals. There are other tools that people use. Any of these tools that you are using, the so-called carbide insert tools, the ones with, the 4 sides or the rounds or whatever, I have some examples up here that you can look at. Any of the easy wood tools, the overpriced stainless steel shanks on those, the fancy handles, all of those tools, while they can be effective, are scrapers. They function in a scraping mode. So the distinction whether you choose to use those tools or traditional tools is really how you want to spend your money. If you want to go the route of traditional tools, you can guarantee that you're going to spend money on a grinder, some wheels, sharpening jigs, and you buy once, cry once. right? You put that grinding system, the club's got one right there, you put that in place, you can take for the rest of the life of the traditional tool, you can go back and back and back and back and put new edges on your tools. That's traditional way of doing it. If you go the carbide insert route, you're saving money initially because you don't have to buy the grinder, you don't have to buy the upgrade wheels if you don't want to. You can still use aluminum oxide wheels. There's nothing wrong with that. But I can tell you for using them, the CBN wheels are really nice. They leave a great edge. There's no risk of the vitrified abrasive breaking apart and shattering, those kinds of things. They don't change diameter. There's a lot of pluses with CBN wheels. You don't need them, but they're nice. In the case of the carbide inserts, they're hard to sharpen if you want to spend the time sharpening them. So, but you're not buying a grinder, you're not buying a sharpening jig, you're not buying expensive wheels, but you got to have continuous deep pockets to over and over replace the carbide inserts that get dull, that are almost impossible to sharpen back to factory standards. Yeah, you can take your diamond plates and you can lap them and maybe bring the edge back on. Some of you may have done that. How many people have tried that? Is it ever as good as the factory edge? No. It'll get you maybe a little bit more life out of the thing, but you're still going to have to chuck that little chunk of C6 carbide into the bin and buy a new one. And that's the recurring expense of these tools. So as I started out saying, it's how you want to spend your money. But I can tell you that the versatility of traditional tools far outweighs what you can do with carbide insert tools. The cutting action is basically very fine scale tear out. Think about that, and think about the quality of the edge you're getting from your carbide insert tools. Is it anywhere close to what you get from a well-sharpened gouge? No. Unless you got really, oily wood, cocobolo or bacote or something like that, and you fine-grained wood, a little bit of oily, you can get a beautiful edge off of a carbide insert tool on those woods. Try that with box elder. Try that with sycamore. It's not going to happen. The woods are not as hard. They're not oily. Okay? So these are not bad tools. There's nothing bad about them. It's what your strategy is in terms of using the tool and what you're going to pay over the length of time. So that's, if you're starting out with these, don't throw them away. They're great tools to learn with. They're actually, in some cases, you can do things in materials like acrylics and things, that those tools are far better as scrapers than a traditional gouge or a traditional scraper would be. Okay, so they're not terribly bad tools. It's just how you want to use them and on what projects. The other thing that people don't realize, that the vast majority of tools that we use as hollowing tools are all scrapers. Every edge that you put on one of these tools, one of these little Sorby things down here, any of the Trent Bosch or John Jordan type tools, many of the tips on those are simply a cobalt type steel or an M2 type steel, a little tool bit that has been sharpened, and they're all scrapers. They all have just a simple negative rake angle, and they have to be presented at zero at the line of the axis presentation. So pretty much all of the scraping form sharpening hollowing tools are also scrapers. People don't realize that, but you do much more scraping than maybe you are aware of. Okay, so I hope this little summary here has cleared up some misconceptions and given you some things to think about in terms of why we use the scrapers and why they actually work. So the take-home points here, as I started out, tool rest position is extremely important, and don't be afraid to tweak it a little bit in the middle of your turning. The burr on any scraper has a limited life, right? It has a short life measured in just a few seconds in some cases on very hard woods. And then scraping is not necessarily a hog out, build it, shape it kind of a thing. It tends to be a refinement thing. Now there are some exceptions. Very good friend of mine out in the West Coast in Oregon. How many people have ever heard of Robo Hippie? Reed Gray is this guy's name, right? He's been around a long time. Reed was for a long time a production turner. He turned lots and lots of bowls and sold them. And he used gouges, but sparingly. He found that he could take a modified scraper that he would use, and he roughed bowls with scrapers. He roughed the entire inside of a bowl with scrapers. He made some modifications. He added, on a traditional scraper, he brazed a different form of steel, a high-quality steel. Anyone ever heard of Tantung? Tantung, something tungsten steel. And he brazed the actual scraping surface on a traditional body of a tool, and that's the tool that he would use to hog out his bowls for many, many years. And then he got better at the quality of the steel got better in the gouges, and all of a sudden he was using gouges as the main thing. But you can use scrapers to do a lot of forming. It's less efficient than a gouge, certainly, but you can certainly, it is possible to do that. So, and then the last thing, as I mentioned just a few minutes ago, just read your shavings on how that works. Questions at this point? Questions? Comments? Insulting remarks? Anything? Yep. The negative rake scrapers work very well on acrylic. Carbides do too. Yeah, that's why. Okay. My battery just came out. Sorry. I do want voltage in this thing. I'm still trying to get the camera energized here. And that is, it was working minutes ago. There we go. There we go. Okay. And now I'll get you a video feed. And let's see, Tom, does that come in? I have to actually get out of here and send the signal over there, and then we'll be cooking with gas, I hope. Let's see if that sinks in there. We do have, well, look at that. And we are adjusting. Any questions at this point? Yep.
On creating the bevel on the scraper, some guys recommend turning it upside down on the grinder.
Yeah, it depends on, Craig asked the question that some guys, when you're doing the bevel on the tool, you're going to create a negative angle back here, your clearance angle, okay? And as that comes in, some people say that if you tilt your platform up and do it this way, you're going to come down like this. I have never had success in raising a good burr that way. I was taught years and years and years ago to have the angle so that you have your bevel down like this on the wheel as it comes around, and that relief angle is created, and because it intersects with the wood, it raises the burr on that upper surface. And I've been sharpening my scrapers that way as long as I've been turning it, as far as I remember. Okay, so that's possible. You could try that, but I like to have my platform so that the presentation angle, I can watch the whole process instead of having to do this, and that whole other side is out of view if it's upside down. There was another question somewhere in the back. That's right. They're left over. They're correct. Yep. So Leroy said that as you're putting the tool against the work, it's the presentation angle that the clearance angle down here, or if you're going to put a negative rake on it, those aren't part of the actual grind. The grind has removed that metal, but it's still requisite that you present the tool properly. Okay. So just to give a quick overview, I'm going to be showing a couple of techniques up here, but I have a collection, if you'll come up later, of a whole set of traditional scrapers that are ground with everything theoretically as of this morning has a good burr on it. There are some specialty tools. I don't know, Tom. Let me bring this around here. I'll go to this camera and hold it up close here. I think if I can. Did I lose signal? It was working, was it not? The camera's on. All right. So where am I? Yeah. So here we are. If you can see this tool, anybody have any idea what tool that is? Yeah. So this is a scraper that people have made. That if you use dovetailed jaws, and you want to put a recess into the bottom of your bowl, you can carve out most of the opening with a gouge, and then you just insert this into the bottom, and that angle right there at the corner creates the proper angle. So this is the correct angle against that reference surface for your dovetailed jaws. Now this is a scraper. You don't need this. It could be handy. I use it once in a while, mostly when I'm doing recesses. You can do the same thing with a detail gouge, but this is one way of just modifying a scraper to work on a particular project or a particular for a particular purpose. Doug Thompson produces traditional scrapers, and you pay the same amount of money for a traditional scraper or a negative rake scraper. It's the same chunk of steel. This is 10V or 10% vanadium steel, 9.75 actually. But this now is sharpened in the format of a negative rake scraper. And let's see if I can, maybe if I do this in the background. I don't know why I'm bouncing, but can you see that angle underneath there? Right, so here's the clearance angle. Here is the top bevel about 15 degrees, cutting down the surface. And this was a traditional scraper, I don't know how many years ago, but all I needed to do was create that relief angle on top, right? And then my standard 80-degree relief angle, all I have to do is just touch up that lower edge, and then the entire curved surface here, all around this edge, now has a burr raised on it that I can go in and hold this horizontal, not have to present it at a negative angle. I can hold it horizontal, and that now becomes a very effective negative rake scraper. You can do the same thing with this is what Sorby sells actually. This is Sorby's response to making a negative rake scraper. So there, I'm holding it now in the correct orientation. You can see that the bevel angle out here, it's about 80, 70, 75 degrees, I think Sorby did it. And then down here, this is about 15 or 20 degrees top relief on top here. There's our negative rake, so that this whole curved edge right here, that whole edge that you see right there, that's where the burr has been raised on that upper surface, right? And now you have a burr here that you can use as your scraper. Okay, let's look at a couple of things that aren't scrapers. Okay, the first thing, the biggest thing that's not a scraper is your gouge, right? They're not scrapers at all. If we look, let me get this focused in here just a tad, and a little bit up. So Craig, I'm going to be, and Tom can decide which is the better view. But in this case, you see that we have the end here. If I'm going to use this gouge on here, can you still hear me okay? Yeah. Okay, the mask is a little, changes the sound for me at least. I'm going to put my gouge here, and I'm going to look to see that, making sure that the contact point in my comfort position of where the gouge is engaging is at or close to that midline point, right? So remember that this is a bevel referenced cutter, right? So here's our bevel. This is a secondary bevel. Don't worry about that. This is the primary bevel. So if I'm going to come in, I'm going to actually encounter that wood like that, right? With a minimum amount of space. There's no relief angle under there. That contacts the wood the entire time. If I'm using this gouge in this position, it's not a scraper. Now I have seen people convert this gouge into a scraper by doing this. How many people have done that? How many people are satisfied with the quality of the cut you receive? Not many. Not many. So this can be used as a scraper, but in the shearing mode. Okay, in the shearing mode. So for example, let me turn that down. We'll talk about this, but if I use the regular gouge, if I just come in and make a cut, I actually need some velocity here. I can come in and just make a cut, and it's a bevel rubbing cut. I'm rubbing the bevel back here. I'm going to come in. This is end grain that I'm cutting like this, right? Or I can come in from the side grain and do the same thing. So all of the cuts that I'm making with this tool are bevel referenced, right, off of that bevel. A tool that people use as a scraper, but it's not supposed to be used as a scraper, is this one. How many people know what that is? Parting tool, right? How many of you have been told that when you put the parting tool on here, you put it at center line, right? We put it at center line. Do you push right in? Do you put that kind of cut? If you are, this is a scraping cut. There's our scraping cut, just pushing straight in because the only point of contact is just that point, right? Just that tip of that tool. If you're pushing that in, that's a scraping cut. Quality of that cut, not very good at all. This is supposed to be a bevel rubbing cut, right? So this is the bottom bevel. I can flip it over because it's symmetric. It doesn't really matter. But the idea is that you will be contacting the tool up here, rubbing the bevel, and then as you lift the handle, you start to engage the cutting edge, and now that's a very efficient cut going in. Let me start down here so you can actually see the cut. But the bevel is rubbing. I'm not pushing in like this, scraping. I am actually bevel rubbing the cut. So the path, if you, are you on, it's on Craig, right? So the path of the tool is actually not a straight line. It is an arc. By keeping that bevel in contact, it allows you to come over the top down to center like that. So you'll be making an arc cut with this tool. So I can come in, pick that up again, keep the bevel rubbing, and then arc that all the way down to the bottom. Picking up the handle, making sure that it's in contact, getting a little bit of chatter at the base here. I'm running out of angle room here. I have to lower the tool rest a little bit. But in this case, this is not a scraper. If you're using it as a scraper, you're doing it wrong. Okay, so that's something that's not a scraper. The last thing that's not a scraper, that is a carbide insert tool, is that. How many people know what that is? Carbide insert tool. This is the Hunter type tool that is a bevel referenced tool. It's not a scraper. If you use it horizontal, get ready to change your shorts. Because it's not meant to be a cutter like this. It is meant to be held at an angle, a shear angle, and you remove material using that shear cut. It's not, if it's put into the wood like this, you're going to have significant problems. But it's not a scraper. Some people will try to angle this up and just use the edge of it like a scraper, and it'll work, but I don't recommend it. One slight change down here, and all of a sudden, that wood is flying off somewhere else. You're going to have a problem. It's going to self-feed and go dig right in. So this tool is not a scraper. You are always going to use this at some shear angle. Find what the sweet spot is, and they're absolutely wonderful tools. But don't use them as a scraper. What we will talk about scrapers, let me pull this camera around one side here. And, oh boy. There we go. It's on. For some reason, it doesn't like maybe the power source or whatever. Think about having your piece of wood. Let me come back up. So there we are right there. I think you can see that, right? So think about mentally putting your protractor right mentally on the piece of wood. And then when you're going to bring the tool in, let me grab just a scraper here. Remember that your scraper is going to come in and either be flat like this, right? Or you can pick your scraper up at some angle until you get to 90 degrees. Now you're slicing. It's no longer an effective tool. So if you tip this up, you need to find what the sweet spot is for the wood that you're using. So what I'm going to do, I'm going to pull the protractor away and just give you an idea. I'm going to have my hand, I'll try to do this way. This would be traditional scraping. I'm dropping the handle, looking, see that the shavings are coming off right over the tool, right? If I change that now and pick this up at a shearing angle, somewhere between 0 and 90, pick it up at a shearing angle, you'll notice, it's a little bounce there, let me clean that flat. You'll notice that the chips are flying off at an angle, and I'm able to make a shearing cut, and the quality of that cut will be superior to that if I just used a flat traditional scraping cut. So this is one way of doing the so-called shear scraping, by taking the scraper and changing the presentation angle such that you can direct. Now, normally I start out with about 45 degrees. That's about there. That's kind of like my normal go-to. But if the shape of the surface or the curve changes, the amount of shear angle can be changed to match the shape. Okay, so this is one way of doing shear scraping. Another form of shear scraping, as I mentioned before, can be done with a gouge with long swept-back wings. You can see that the wings here are fairly long and swept back. Let me show you that grind. Okay, this is a long swept back ground. So I can do most of my shaping and hollowing out here with the tip. I can ride the bevel, no problem, inside and outside the bowl. And then the other thing I can do is put that on the tool rest and have it well above center. So contacting, if you were to look for from the end of the lathe, maybe like between 8 o'clock and 10 o'clock presentation above. And you can roll this tool into, let me shape this off here a second. It's a little bouncy since I turned this flat this morning. So you'll notice that was a bevel rubbing cut that I just faced that off. So I can I rub the bevel, roll it into the cut, and I'm able to just come straight across like this. So you hopefully are able to see that cut progress. But shear scraping, you drop the handle quite low, like this, and then use the back wings. Let me see if I can, there we are. You use this back wing over here, You can reference if you want, but what you're going to do is roll that tool in, and you'll also notice that I'm going to bring the handle this way. This little staccato here. Bring it in this way. If this is 90 degrees, so that would be slicing. Anything other than 90 degrees that's not horizontal, you're able to come in and generate very, very fine shavings using the wing of that tool in shear scraping mode. What's that? And don't touch the top wing. You don't want to roll all the way. If you roll all the way over, you have major problems. But this is a cutting tool, a shearing tool designed for that. But if you just engage that edge, it can be a very, very effective shear scraping cut, generating lots of little fine, wispy shavings. Okay, so that is that is a bowl gouge that is being used as a scraper only because the geometry of the grind allows me to. If you did a 40-40 grind, don't try this. There's not enough wing there to function as a scraper without getting a decent catch, because the 40-40 grind does not lend itself to this. Yep. This one, you round the bottom. Oh yes, yeah. I do the same thing. If you when you get a brand new gouge, when you get a brand new scraper, it comes directly from the manufacturer, and it has 4 hand slicers on all 4 corners, right? And you try to use it, and it's very uncomfortable. It's extremely uncomfortable. What I do with mine, as soon as I get it, every one of these, you can see it's been done. I go take it to my belt grinder. My belt, what is it, 6 by 30, 4 by 36, whatever it is, 6 by 48. And I knock the corners. I round the corners. I put a slight chamfer on all of them. And you have to do it once in the entire life of the tool. I've had this tool 20 years. You have to do it once in the life of the tool. But by knocking those corners off, it prevents those sharp edges from not only digging into your hands, but digging into the tool rest. And for those of you guys that are still using the cast iron tool rest that came with your lathe and do not have the hardened steel tool rest on top, that dig in cast iron is very, very real. How many times did they tell you that once in a while you have to take a file and go flatten your tool rest if you're using one of those cast iron tool rests? So every one of these tools has had those corners relieved. So none of them are sharp. They're much more comfortable in your hand. Another tool that I made, maybe Craig, can you catch that one? Where am I here? I'm just trying to hold it still. All right. So I made this entire tool. I bought the actual high-speed steel cutter from, I think it was Trent Bosch this past summer, and it's a curved cutter. Kind of, they call it like a heart, half a heart, or a D cutter, like this, or a teardrop. This is part of a teardrop. I guess that would be a better teardrop. That shape right there. This, I think, is, well, this is crown. It's not Sorby, but it's crown. But that's another cutter. It is ground. In this case, this cutter here is ground for a traditional presentation, so it has to be negative rake. There's no top bevel on this. But on this tool that I just got this past summer, I made this as a negative rake scraper for cleaning up the inside of bowls, where it has right there, you can see that little glint along the top, a slight, maybe 3 millimeters at the most, wide negative rake on top, and then about a, I don't know, 65, 70 degree relief angle around the bottom. And then that is simply screwed to, with the screw that comes with the insert, to a piece of, I think that's what, 5/8 inch cold rolled steel. A small relief is cut into the top of that. You can see that, and then there's drilled and tapped for that. I think this is actually 1/4 if I'm not mistaken. But this is a tool, instead of spending $150, $175 to buy one of these commercially, you can make one on your own for, I think the cost of the cutter was like $35 or $40, whatever it was. Going to last a long time, high quality steel. This metal probably cost me maybe $6 at the most. And then at the bottom where it goes into the handle, I actually hold this in my chuck jaws and turn that round with a file on my wood lathe. Took a while. I don't have a metal lathe, at least one that works right now. But if you know somebody with a metal lathe that can turn down one of these bars, easy, cheap. And this is a very, very effective tool for the inside of bowls. Now, in the interest of time, I'm not going to put one on. We can maybe put one on later. But I know we're coming up on close to our time here. I got started a little bit late, but this is mostly what I wanted to talk about with respect to using these tools. If you have, this is a set of John Jordan hollowers, the small ones. I got all three sizes, but the ends of those tools are just basically high-speed steel. Here's our, straight versus curved. Obviously, that makes sense for hollowing the main part of it out and then going underneath the shoulder or whatever with the curved tool. But at the ends of each one of these, they are held in place by set screws. Right there, you can see the set screws. And each one of these is this 3/16 inch square. They call them tool bits. You can buy them at, machine shop, supply stores, these kind of things. You can buy them online, Amazon. You can buy them from MSC. MSC Direct is an industrial material supplier. But this is nothing more than sharpened as a scraper. It has a relief angle on the one side. If we go to Craig's side, Craig's camera, it has a relief angle on each one of those tools. It functions as a traditional scraper. You put it right at center line, and you can hollow out your vessels and ornaments and anything else you want to do. But these are nothing more than scrapers. Now, they're not sold as scrapers. They're sold as hollowing tools because they can get 4 times the amount of money because it's a hollowing system now. It's no longer just a chunk of steel in another chunk of steel. So, with a holder. You don't want to do them by hand. I have seen people at the AAW symposium hold them with a vice grip on a platform. Yeah. Yes, you don't. What you want to do is get yourself a chunk of aluminum or some block of metal that you can drill in and put a set screw in there, mount them in that block, and then slide the block on your platform, because your fingers are valuable to you. You can go and get, manicures, pedicures if you're sharpening with your feet by running your fingernails in, but please don't do that. That's scary. All you need to do is have that wheel catch it once, and it's gone. It's somewhere in your shop. And the only way you can find that is through a total cleanout, which is terrible to do. Or you have to go magnet fishing and hope that you find it. So I sharpen mine. The ones that have a substantial curve, John Jordan years ago made a sharpening jig that goes into the Wolverine platform. You drill a little dimple in the top of the arm, and then you sit that in there, and you can just rock it back and forth, and you make a perfect scraper profile at whatever relief angle. The what? There can be, depending upon the design of the tool, but it's a little rod, and you just simply insert the thing, screw it, a little wing nut kind of a thing on there, and you just rock it back and forth, and it sharpens it really effectively. The angle is not critical, but I will say that from anywhere from about 80 degrees down to about 75, 70 degrees is, for me, the sweet spot. If you start sharpening your tool bits or your general scrapers closer and closer to 60 degrees or even 50 degrees, the edge out, the tip, the actual cutting edge where the burr is going to be raised, becomes more and more acute. It can actually set up more vibration. And the other thing is, remember, you're sharpening the bottom of that thing. The more acute you make that angle, the longer your bevel becomes. You are grinding a hell of a lot more metal with one of those acute little angles than you would with a 70-degree relief angle on there, or an 80-degree relief angle, which is a much, much shorter, I'll call it bevel, that you've got to grind away to make sure that you meet and raise a burr. So I don't recommend getting too narrow. If you're grinding something like this is 35 degrees on this side and like 20 degrees on this side, on the upper surface, to do a negative rake scraper. So I do have to raise a burr on the bottom, but this also, I can also go in very deep on a bowl and finesse that right out all the way to the rim. And one thing I do want to remind people is that this is the geometry of the bowl, as if you're turning a bowl. Remember, even though you have uniform wall thickness on a bowl from the bottom to the top, that's the goal, right? It doesn't have to be perfect. But as you're spinning this, there's an inherent instability of the rim area that even though you've got it trued up, by putting a little bit of force on this, it still can create a slight amount of chatter. Now, if you've got a bevel reference surface on your gouge, that's a whole hell of a lot less of a worry because you have a reference surface and you're allowing that gouge to cruise along on that reference surface, right? So it's a lot more stable to go in with the gouge and bevel in full contact with that. If you have this on the lathe and it's spinning, and then you start coming in with just the edge of the scraper touching, any instability on this bowl is going to be manifest by kind of bouncing or variation that you've got to be ready for, and that you have to have enough, what's the term? Testicular fortitude to be able to slowly glide that through that scraping cut that you have, because you're only contacting it at the edge. You have no bevel reference when you're using one of these tools. So if you have any kind of run out, we'll call it, on the bowl, or if the wall gets starting to get very, very thin and you get flexing under power based upon differences in density, the bowl tends to oval and go back to round, if particularly at high speed. That little bounce, that slight amount of bounce, is not a big deal with a gouge. You put that on a scraper, you'll be blowing that bowl up in minutes because it can catch and bounce, and then you're done. So again, scrapers are finesse tools. You have to be ready. If you're going to be using a traditional scraper and you're going to be putting it on that tool rest, you better be edging that in very gently and waiting for that initial contact. Because what? This is going to self-feed. It's going to pull, it's going to want, as soon as it engages, there's going to be a force that's no longer pushing back at you. It's pulling it away from you. And if you lose control of that tool, you're going to get a catch. You're going to get a dig in. And that's a physical reality of the physics involved with the rotation. With a negative rake scraper, since you're at zero, the likelihood of self-feeding is extremely small. But you still have to do a finesse cut. It still has to be there to just kiss away that edge and develop those very, very fine shavings. Because the point of this is to take out the ridges left by a gouge or whatever else you're using. It's not to create the perfect finish. The only perfect finish I know is off of a tool is on a spindle using a skew. Where you can, anybody watch on over the internet, this guy Steve Jones in England, okay? He is the master, a best skew person I've ever seen. And that includes people like Alan Lacer and, and Jim Ector and all these other people. But this guy in England, third generation woodturner, he's a master. He can produce a glossy glass surface finish of a skew on hard woods like white oak right off the skew. Don't even need to sand it. It's the only perfect finish I've ever seen off of a lathe tool. Despite what Stu Batty or Mike Mahoney or everybody else says, they're still not perfect finishes. They still require abrasive sanding to complete the project. But this is a finesse tool to move you closer to the point where you don't have to do as much sanding as you would if you didn't have a scraper. So scrapers are important. They're not the be-all and end-all, but it's a very, very effective tool in getting you further along to create that perfect surface without as much sanding as you might be doing now. Other questions or comments? If you're interested in we can have a look at some of these tools, we can talk, and we have a few minutes, I guess we can demonstrate a couple more things, but not to the whole group. I think we're almost out of time, is that right? All right, folks, thank you so much, and we'll see you again.